Okay, so the theme today from everybody is safety. So some interesting statistics. 1 in every 3,000 e-scooters goes into a catastrophic failure. Not as a result of damage, but as a result of a charge or discharge. 1 in every 44,000 EVs goes into a catastrophic failure. Charge or discharge. 1 in every 44 grid scale storage arrays goes into a catastrophic failure. About 1 in 10 million cells will fail over the arc of its life based on today's chemistry and manufacturing. The challenge to shifting off of today's chemistry and manufacturing is we're really good at it. Like in a gigaplant, you make about 50 cells a second, which means every day you're making about 5 million cells out of that plant. And a 20 gigawatt hour plant is not a massive plant today. So at Viridi, what we did is we looked at it and we said, okay, what's the chemistry that we have today? And is it possible to use that chemistry in the energy transition? So we went the opposite way, because I'm not a chemist, I'm not that smart. But I looked at the chemistry and said, if we can use material science and architecture, can we control the release of energy from the cell, let the cell go in the thermal runaway, and prevent propagation inside of the pack, and still maintain energy density and all those other characteristics we want? And that's what we did. We designed the pack, put it through destructive testing. According to the DOE, I destroyed more packs than any other organization in the country. We were doing 15, 20, 40 kilowatt hour packs, complete destruction 3-4 times a week. Today, there's a 600 kilowatt hour installation in the medical center. The installation was done without any additional fire suppression, ventilation, or construction. And the pack had been tested to a residential standard, both 1973 and UL 9548. So what did we do? We took a really good cell from LG. We created a really unique module, and then with that module inside of our pack, we created an architecture and surrounded it with material science. What's the market? The challenge we have today is that we don't have a challenge with our grid. Our grid has plenty of energy, and it has plenty of transmission and distribution capacity. We have a time of day issue. Right? We all want to turn stuff on at the same time of day. According to the DOE, if we make 10 units of energy upstream, we sell 3 through the electric meter. So we generate 10, we transmit it, we distribute it, we deliver it, but the customer only buys 3. If you put storage behind the meter, we can take 3 to 6. So we can double the units of electricity you buy through your utility meter just by putting storage at the end of the line. By doing that, you don't have to add a wire, you don't have to build a transformer, you don't have to do any more generation, you optimize renewables, you balance the grid, and you give grid operators, because of our IoT and our connectivity, the ability to shed load instantly. So if you have 6, 10, 20, 30 gigawatt hours of distributed storage on your grid, push a button and 3 seconds later, you can shed that load. So you can get rid of overheating on transmission lines. You can manage maintenance and upgrades. All of this without interrupting a customer and giving the customer 100% resiliency. So our model, and today Viridi does, we did about 25 million in 25, we'll do about 75 million this year. We have contracts coming in that can take that to 300 or 400 million. But our role is really install packs in C&I applications and tie those together through a VPP that either the utility, the customer, or we control. That's it.